All right, hello everybody. Welcome to another video. Today we're going to be talking about the discriminants. You might have seen this equation somewhere. Hopefully you have. We'll talk about that a bit more. But the discriminants, actually let's use a different, more bolder color, thicker marker. The discriminant is b squared minus 4ac. And actually I'm going to say it's equal to d. We'll talk about what this equation's value really means. That's pretty much the whole point of this equation. But hopefully this equation sounds very familiar. It is directly from the quadratic formula. Maybe you've seen the quadratic formula in some sort of reference table. Maybe you're very familiar with it because you're taking the SAT, etc. The discriminant is directly from the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And hopefully that's familiar. You'll understand it better if you're familiar with this equation. You must know this equation for Regents, SAT, etc. And you'll notice that this discriminant equation, this one that I introduced you just now, is the same as what's underneath the square root symbol, or the radical of this equation, b squared minus 4ac. And that is not coincidental. That is on purpose. This part of the quadratic formula tells us so much about the roots of our equation. Now, to first better understand what the discriminant is, I have here a definition directly from Wikipedia. It's going to sound a bit complicated, but we'll break it down throughout this video. So it states, in mathematics, the discriminant of a polynomial is a quantity that depends on the coefficient and allows deducing some properties of roots without computing them. Sounds very complex, but I promise you it is so easy. So let's talk about this. Let's think of a very basic quadratic problem in order to understand this. Let's say x squared minus, let's see, minus 8x plus 12. And actually, let's call this a function of x, f of x. And yeah, so if you know basic algebra, or maybe if you know factoring rather, you'll know that this is factorable to x minus 6. Sorry about that, I was thinking about it for a second. And x minus 2. Factorable basically means we try to find its factors while remaining its equivalent form. So here, this equation here is equal to this equation up here. We just factored it out. And what this tells us is that the roots of our quadratic are 6 and 2. And if you really want to call it that, 6, 0 and 2, 0. How do I know that? Zero product property. This means that our problem in general has 2 real roots. Right? That makes sense, because when I plug in 6 into this function, it'll equal to 0. And when I plug in 2 into this function, it will also equal to 0. Makes sense. Awesome. So what if I were to use this b squared minus 4ac formula I just introduced to you a few minutes ago? Let's talk about it. So you should know that every quadratic follows a similar formula, or hopefully should follow a similar formula. If you're taking a standard exam, you might have to derive it or change it so that it follows this formula. Usually you'll see it's something like f of x is equal to ax squared plus bx plus c. Ax squared plus bx plus c. It usually follows that format. And we have 3 variables in front of the variables. Or 3 variables in front of the x's. Actually, one of them doesn't have an x, but the other 2 do. But you get the point. You have a, b, and c. A, b, and c. So when we mention these letters in b squared minus 4ac, we are directly referring to these letters over here, respectively. Hope that makes sense. So I'm going to plug in these values and see what happens. So b in this problem is equal to negative 8. And we're squaring that. Makes sense. Minus 4. The a value here is going to be 1. There is an imaginary 1 in front of the x squared. 1. And then we have c. c is equal to 12. Now, we're going to solve this out, and we're going to see that this is equal to 64 minus 48 is equal to 16. And the square roots Actually, we're not going to find the square root. That's a common mistake. We'll talk about that later. And so we have the discriminant is equal to 16. Now, let's talk about some rules, because I think it'll make more sense if I just mention the rules right now. When this discriminant, whatever value this is, as before we said it was equal to d, so b squared minus 4ac is equal to d. If d is greater than 0, that means that we have two real roots. That means our quadratic has two numbers as our answer that are real numbers, that are numbers on the real number system. If d is equal to 0, we have one real double roots. One real double roots. And if d is less than 0, we have 0 real roots, only imaginary roots. And if you don't know what real roots are or imaginary roots are, I would highly suggest you to watch a video about the number system. It is amazing how our numbers work. So please, please, please check that out. So here we see that our d value in this problem up here, our d value here is 16. And that is very clearly greater than 0. So that means we fall under this definition right here. We follow under, let's choose a new color. We follow this definition right here. D is greater than 0, so we have two real roots. And we saw that, because remember, when we checked out the roots over here, we found out it was 6, 0 and 2, 0. Once again, those are two real roots. Now, what if we had d equal to 0? We're going to do a problem just like that right now. So let's call it a different function. Let's say g of x is equal to x squared minus 2x plus 1. Fair, right? And once again, if we factor it out just like we did up here, we can factor this out to x minus 1 and x minus 1. x1 minus 1 times x minus 1. Cool, right? Cool. One thing I want you to notice is that our factors here are repeated. Notice here in this function f of x, we have two different factors going on. We have x minus 6 and x minus 2, whereas in g of x, we have one factor repeated twice, x minus 1 repeated twice. Cool. Now, we know that means that our factor, our one and only factor, is 1, or 1, 0 is our x-intercepts. Now, let's see how b squared minus 4ac works out here. Let's see how that discriminant we're talking about looks here. So I'll write it down over here just for your sake of understanding. B squared minus 4ac is equal to d. So let's plug it in. B squared, b is negative 2, minus 4, a is equal to 1 here, and then c is also equal to 1, equals d. And we get 4 minus 4 is equal to 0, 0 equals 0. Bam. And that means d equals 0. Technically, yeah. And that is the second case we just spoke about. So this was case 1, this is case 2. This is exactly what I was talking about. We have one real double root. This root appears double, appears twice. Except it's just 1 point. 1, 0. And that is the only number that can satisfy, or only real number rather, that can satisfy this expression right here to make it equal to 0. Cool? Alright, and the last thing I want to talk about, sorry for the cut there, had to fix something. But the last thing I want to talk about is when we have no real roots, when d is less than 0. So let's think of an expression right now. We've done h of x, we've done f of x, we've done g of x. Let's do h of x. Let's do h of x is equal to x squared. Let's see. What could be a good value for b? Let's say it's negative 50, right? Negative 50x plus, I don't know, man. 1,000, sure. And right now, I'll tell you right now that this has no real roots. But I want to prove this using the discriminants that we talked about we spoke about before. So b squared minus 4ac is equal to d. Let's figure out what value d is, and from there we'll consider its relationship with 0. So let's plug things in. So b is equal to negative 50. So negative 50 squared minus 4a. Remember, there's an imaginary 1 over here. A is equal to 1. And then c is equal to 1,000. 1,000. And so if we were to solve, let me just do some quick math over here. You will get that d is equal to negative 1,500. Now, notice, this is significantly less than 0. So therefore, we applied this third scenario we learned about. When d is less than 0, we have 0 real roots. And that is why when you graph or when you try to use quadratic formula for this problem, you will get stuck. Because in the quadratic formula, let me find that real quick. And why don't we do this? Why don't we just drag this with us? Let's talk about this quadratic formula real quick, right? In this quadratic formula, actually I'll make it a bit bigger so we can analyze it a bit better. In this quadratic formula, we have a radical where the b squared minus 4ac is. This precious symbol right here, this radical, this square root symbol, whatever you want to call it. So everything inside of this square root, inside of this radical, has to be greater than 0. Because if I'm asked if b squared minus 4ac, for example, is equal to negative 1, what in the world am I going to say for this? If you don't know about imaginary numbers, what are you going to say about this? Like, it's not equal to 1, because 1 times 1 is equal to 1, not negative 1 times. Actually, negative 1 times negative 1 is equal to 1, but that's just not how it works. So, that is why when we have a b squared minus 4ac that is less than 0, we cannot solve the problem. We can't even find what this is. So forget about this whole thing. We can't find a single real roots with this equation if this is less than 0. Because, well, you don't know where to go. What's the square root of negative 1? That's pretty much what you got to know about the discriminant. One thing I want to talk about, though, one more thing at least, is graphically, what does it look like? Graphically representing different discriminants. Graphically representing different discriminants. Cool. So, let me just draw 3 axes here. I'll just actually, you know what? Sure. For you guys, I'll draw it more than just the positive x and positive y axes. So let's say we have this axis over here, and why don't I go ahead and duplicate this? Is the duplicate button? Duplicate. Oh, I don't want that extra line in there. So let's do this. I will make a bunch of these axes. We're gonna take a look at how this functions. Cool. So imagine this as being your typical XY coordinate plane, your Cartesian coordinate plane you're familiar with. XY, XY, XY. So when d is greater than 0, which should be pretty much most of the quadratics you've solved in your entire life as of now, you'll notice that it's going to be something among the lines of this. Quadratic will look something like that. We have here our vertex, of course, and notice that it crosses the x-axis not once, not 0 times, but twice. Once over here and once over here. These are our roots. These are the values our quadratic formula spits out to us. And that makes sense, because remember, when d is greater than 0, we can actually solve the quadratic formula, and we get multiple distinct roots. Next, let's talk about when d is equal to 0. That means we have 1 root, as you remember. Hopefully you remember. And what does that look like? That looks like this. Now, once again, not all of your quadratics are going to look exactly like this. They might, for example, flip it over the x-axis, or maybe, there's a bunch of different transformations. I'm just here to show you the general shape that some of them may have. So this, notice here, D is equal to 0. We said that is when we have one real solution. And that means it intercepts the x-axis one time. Intercepts x-axis one time. And actually, I'll write this in for that too. Intercepts x-axis twice. Because that's true. Intercepts twice. Cool. And last but not least, when D is less than 0. Let's use orange. So it'll look something like this. And notice here, when D is less than 0, when we can't use quadratic formula to get a real number, because, well, the square, what's under the radical is negative, and we don't have any real roots, our graph will not be touching the x-axis. It will not be touching it at all. Does not have any x-intercepts. Bam. So graphically, that's kind of what it looks like when you have discriminants of these values. It's very important to recognize what you're working with. Sometimes, for example, if you're asked, hey, how many solutions does this so-and-so quadratic have, you just graph it and just see how the graph looks like. And if it crosses the x-axis twice, you know it has two solutions. If it crosses the x-axis once, it has one solution. And if it doesn't cross the x-axis at all, it does not have any x-intercepts. So very, very easy to understand this once you get the hang of it. We can do more practice problems in the future, but hopefully that makes sense. If you have any questions, please let me know in the comment section down below. Please make sure to subscribe, and I will see you later.